Hello everyone, my name is Zongfu An, the PhD candidate from NMNDL School of Chemical Engineering and advised by Professor Piljin Yu. Our lab research topic is lithium-ion battery, nanostructure, nanoreactor, and some microfluidic device. Today I will introduce a kind of lithium-ion battery, lithium-sulfur battery. Also a part of lithium-sulfur battery, how to increase the property of lithium-sulfur battery. We select the part of this device, it means separator, also a kind of membrane. We're using some other material to modify the separator, also using some chemicals. This chemical composite means lithium-ion channel, a kind of from biomimetic from cell, bacteria cell, cell membranes. You can see the red one is it means lithium ions. Lithium ions is transport in these channels. This ring-based channel. This ring is current ether, a kind of chemicals have very strong affinity with lithium ions. And the yellow plate is a kind of supporter. This supporter means it will order the current ether, as a tube tunnel, and can make the lithium ions have a fast transmission. This part is structure of the lithium-sulfur battery. Now, the first layer is lithium metal as an anode, and after lithium metal, this part is electrolyte and the separator, electrolyte and RgO sulfur composites as a cathode. Very commercial use the RgO, but some person using some CNT or some other carbon-based materials. Lithium-sulfur battery is a kind of lithium ions, but different with other lithium-ion battery. Lithium will react with sulfur to produce the lithium polysulfide and to reduce the polysulfide to lithium metal and sulfur. But this cycling is charging and discharging. But if the polysulfide cannot reduce to lithium metal and sulfur, and if the polysulfide is moved to lithium metal, the anode, the activity material will lost, and the capacity of lithium-sulfur battery will decrease, and the property of this battery also will decrease. And very long time ago, it cannot use. So we tried to modify the separator, and means using the single lithium-ion channels, and the chemical structure and the 3D structure is like this. Here is 18 chlorine 6. It's a kind of chlorine ether. It will the molecular stacking layer by layer and contribute tube like channels, and the lithium ions will turn in the center of the chlorine ether, like here. And the supporter, nickel dimite, you can see here, it will make the crown ether like channels, not very random staking or random structure. It's very important because if crown ether cannot still like a tube like channel, the lithium ion cannot transfer very fast and very perfectly. The subject we chose the PP, polypropylene. This membrane have many pores, and we filling the pores. You can see the left side is same image of surface and the cross. You can see many pores in the PP membrane, but after modification, the pore is lost. We cannot find, and the cross is also. It means the modification is very successfully, and the polysulfide cannot turn it into the pores. Also, the thermal stability is very very important in the separator. After heating at 150 degrees, 10 seconds later, the bare PP membrane is changed, but the modified PP membrane is still correctly. Another important point of the separator, lithium separator, is very important, is lithium ion transfer number. You can see the bare PP lithium transfer number is 0.23, and the modified PP membrane is 0.47. It means the lithium is transferred very fast and very perfect than the bare PP. CV plot is also can find some information. You can see I marked this peak and this peak is polysulfide. You can see the left image is bare PP and the right image is modified PP. The bare PP, you can see the end peak is polarized. It means the polysulfide cannot reduce to the lithium and sulfur, but the modified PP membrane, using the modified PP membrane, the peak, the graph is not different changed, and you can see each peak is also still perfectly. It means the polysulfide is reduced to lithium and sulfur. Also, the other point of the lithium sulfur battery is polysulfide diffusion test. There are three parts. The left part is polysulfide solution, and the central part it have a little membrane, and the right part is electrolyte. We use DOL and DME. You can see using the bare PP at the start time, 0 hours, a little polysulfide is diffused to the electrolyte, and after 3 hours, very many, and after 12 hours, you can see here there are no. It looks like supernatant. It means many polysulfide molecule is diffused to right side. But after using the modified membrane, you can see 0 hours, 3 hours, there are no polysulfide diffused. But after 20 hours, after 12 hours, there are a little polysulfide diffused to the right side. It means the modified membrane can broke the polysulfide diffusion. So it's also it also can increase the capacity or property of lithium sulfur battery. Last, we using the cycle test. The red one is modified PP, and the blue one is bare PP. The left scale is capacity of the battery. We can see the red one after 100 cycles charging discharging test. The red one capacity of lead one is maybe lost 10 or 20%, but the blue one is more than half, more than 50%. So it means the capacity lost, and capacity lost means the activity material lost. It means maybe polysulfide is changed to lithium metal anode, and it cannot. Another way is polysulfide cannot react to lithium and sulfur. Thank you for your attention. Thank you.